Good morning, everyone. Today we'll be talking about complex numbers. A little further, we'll be doing some operations with complex numbers. Your assignments here at the top of the notes. We'll get to that, of course, after the notes here. So, operations with complex numbers. Consider 2 plus 3i. Since 2 is a real number and 3i is a pure imaginary number, the terms are not like terms, okay? And they cannot be combined. This type of expression is called a complex number. Okay, so yesterday we worked with imaginary numbers like 3i, pure imaginary numbers. A complex number is a combination of a real number and an imaginary number. They're not like terms. Okay. Here you've got the definition of complex numbers. We've got a couple examples here. 5 plus 2i, 1 minus 3i. Okay. So complex numbers, guys, we write them a plus bi, where a is the real part and b is a real number times the imaginary. Okay? Two complex numbers are equal if and only if their real parts are equal and imaginary parts are equal. Okay? That is, a plus bi is equal to c plus di if a equals c, b equals b. So if we are equating complex numbers, we can find the values of x and y that make this true. Okay? The way we do that, well, we've got to do some simplifying here. So 3x minus 5 plus 1 minus 3i is equal to 7 plus 6i. So, yikes. A little bit. First time around, 3i. So what's the real part here? The real part of this left half is 3x minus 5, and the real part of the right half is 7. So we can set the real parts equal to each other. And we can find that x would need to be 4. Divide both sides by 3. X is 4. That would make the real parts equal. Well, what would make the imaginary parts equal? Set them equal to each other and find out. 5 minus 3 is equal to 6i. Let's divide this side by I. That would leave us y minus 3 is equal to 6. Add 3 to both sides. Here, y equals 9. Okay, so we found x and y so that these two numbers would be equal. You guys go ahead and pause and try to do the same process here. Problem 4. So if you've tried this on your own, again, you're looking to set the real parts equal. The real parts are the parts that aren't being multiplied by I. So the real parts are 5x plus 1 and 2x minus 2. So you set those equal to each other to give you an equation that you can solve for x. The imaginary parts are the parts being multiplied by I. So 3 plus 2y is equal to y minus 6. And you can solve both of these equations. So to solve for x, we would subtract 1. 5x equals 2x minus 3. Subtract 2x. Make 3x equals negative 3. Or x is equal to negative 1. On the right side here, divide by I first. 3 plus 2y is equal to y minus 6. Subtract 3. So 2y is equal to y minus 9. Subtract y. 3y is equal to negative 9. Okay? The commutative, associative, and distributive properties of multiplication and addition hold true for complex numbers. To add or subtract complex numbers, combine like terms. That is, combine the real parts and combine the imaginary parts. So, to add and subtract, 5 minus 7i plus 2 plus 4i. So, again, combine the real parts. So, 5 plus 2. Okay. Combine the imaginary parts, negative 7i plus positive 4i, so plus 4i. 5 plus 2 is 7. Negative 7i plus 4i, that's negative 3i. So that is how we add complex numbers. To subtract complex numbers, guys, I would just treat this negative like a negative 1. Distribute. Okay, so this is 4 minus 8i minus 3 plus 6i. And then we're combining like terms, we're combining like parts. So 4 minus 3, that would leave us 1. Negative 8i plus 6i, that's negative 2i. Okay. You guys to go ahead and try 5a and 5b, so go ahead and pause and try both of those. All right, so on this first one, combine the real parts, so negative 2 plus 1. Combine the imaginary parts, 5i plus negative 7i, so that'd be minus 7i. So negative 2 plus 1 is negative 1, 5i minus 7i, that's a minus. Okay. For 5b, I would have probably distributed that negative. 4 plus 6i plus 1 minus 2i. Then combine the real parts, so 4 plus 1 is 5. Combine the imaginary parts, 6i minus 2i, so positive 4i. Okay, so adding complex numbers, subtracting complex numbers, pretty straightforward. It's very much like just combining like terms. Okay. Complex numbers are used with electricity. Guys, this is all coming out of the textbook. What it's saying, we can use FOIL to simplify, to multiply complex numbers, and so that's what we're going to do. Use the FOIL method to multiply complex numbers. Okay, so first times first, so negative 6 times 3, that's negative 18. Outer, so negative 6 times negative 3i, positive, negative times negative is positive 18i. Negative 1, I times 3, that's negative 3i. And lastly, negative I times negative 3i, positive 3i squared. So simplifying this, we've got negative 18. Combine the imaginary parts, the like terms, if you will. 18 minus 3 would be positive 15i. And if we recall from yesterday, I squared is really negative 1, so this is plus 3 times negative 1. So this is negative 18, continue simplifying, plus 15i minus 3. Oh, hey, look, we've got real parts that can combine. So those combine to negative 21 plus 15i. Okay. Thanks for watching. Hope the DLD went smooth. Pretty straightforward lesson.